Hello, everyone. Thank you very much for joining us today. My name is Sören Böge. I'm working in the product management at Basler AG, and I will be the moderator of today's webinar. First off, the obligatory instruction. Our webinar today will be about 75 minutes and will be starting very soon. Please take note that to ensure a smooth presentation, your mic will be muted throughout the whole section. If you have any questions, please feel free to ask at any time in the chat box on your right side. We will collect all questions and will try to answer them during the Q&A section right after the presentation, or today also in the extended Q&A session after the webinar. If time does not allow answering all questions, we will follow up via email after the webinar. We also prepared a very short survey, which we kindly ask you to fill out after the webinar ended. The survey will help us to keep great quality of webinars for you. In today's webinar called How to Optimize Your Vision Application for Real-Time and High Performance, we will take you along and show you how our industry-leading SDK Pylon will help you to get out the maximum performance of your vision system. With this high expectation to match, I will now hand over to Momchil Binev, who will be the speaker of the webinar. After joining Basler in 2007 as Senior Support Engineer, he joined the product management in 2017 as Responsible Product Manager for the Pylon Camera software suite. In this role, he is responsible for making decisions concerning the Basler software strategy for all relevant markets. And with nothing further, I would like to hand over to our speaker. Well, go on then, Momchil.
Thanks a lot, Sören, and also hello to everyone from my side. First of all, many thanks for you taking your time to attend this webinar. Today we're going to speak about frequently asked questions about Pylon, GigiVision, USB 3 vision cameras, and all complementary hardware that you typically use in a machine vision system on both Windows and Linux. We're going to share with you and demonstrate some best practices and give you some tips and tricks in order to tweak your application for the best performance and for real-time capability. So enjoy the session, and I'm really looking forward to getting your questions at the end. I first want to start with a short retrospective on what has been going on in terms of Pylon in the past months. So first, we started our webinar series with an introduction to the Pylon viewer in order to give you an idea how to evaluate cameras, how to design your application, and how to start developing with Pylon. In the second webinar, we covered the Pylon C++ API, and we demonstrated the benefits for you in order to increase your productivity and decrease your total project development costs. Both webinars are recorded and available as videos on demand on our website so that you can recall them at any time. During and after these webinars, we got a lot of feedback from you, and we really appreciate that a lot. And as it turned out, the majority of you is actually looking for exactly these practices for optimization, for tuning, for both single and multi-camera applications in order to get high performance out of it. And this basically was the trigger for today's webinar. So I want to encourage you also today to give us feedback at the end of the webinar so that we can consider it for upcoming webinars. And here we come with the agenda for today. We're going to dive in some GigiVision setups optimizations on both Windows and Linux. Then we're going to repeat the same story for USB 3 vision. And as you see, we have prepared a lot of live demos. And depending, of course, on your questions, we can have even more live demos during the Q&A session. Eventually, we're going to summarize the session. And of course, as Sören already mentioned, we are planning to have a half an hour of extra Q&A session for those of you who are interested in it. But first of all, we want to start with some arguments for why our customers prefer Pylon versus third-party SDKs. And we at Basler stand for 4 major brand values, which are reliability, easy to work with, best value for money, and industry leading. In the previous webinar, we covered 2 of them, the easy to work with and the best value for money. And today we're going to mainly focus on the reliability aspect of Pylon. So when speaking about reliability from the perspective of Pylon, we think of the following main points. So first of all, you don't need to write that much code within Pylon. So according to our competitor analysis studies, in average, you save 60% of your program code when using Pylon. When writing Lisp code, of course, this means that the probability that you make mistakes also during your development, but also in your final product is higher. And by that, of course, you increase the stability. Especially when considering Windows, we always make sure to provide you with certified drivers, which is also, I think, a very important point to consider always, because when you start deploying your application at customer side, or when you are doing an upgrade of the software on the side, on the customer side, you basically prevent from the end user making any errors. What we're, however, mainly going to focus on today is that Pylon is a field-proven, optimized, and robust software that has been in place for 14 years now, and it is installed in multiple 100,000 installations. In addition, although Pylon is already optimized for high performance and real time, we provide you with even more functionality and ways to tune and tweak your application in order to get even more performance out of it. And this is exactly what we're going to demonstrate today. And last but not least, of course, when you decide to set up your product on a given software SDK, we ourselves make sure that we secure your investment by keeping Pylon backwards compatible, so that both your development costs but also the maintenance costs afterward are always kept low. So by having said that, we directly dive into ways to optimize GigaVision setups, and we start with Windows. First, I want to start with some typical error messages that you usually come across when using GigaVision cameras and hardware. And I think the most prominent error message of all of them is this one. In orange, you see the typical error code, which is also coming from the GigaVision standard. And in the black color, in dark blue color, you see the error message that is coming out of Pylon. And in this case, it basically says that you are losing image data. And when losing image data, it is usually not only a problem of a camera or software, or you have to consider the complete setup. And a complete setup in terms of GigaVision, of course, can contain of a network adapter, switch, Ethernet cable, of course, the PC itself, and the camera. And within Pylon, we give you directly also an idea of which camera parameters you can tune in order to prevent from error messages. So a second error message is probably a consequence of the first one. This typically happens when you have massive image losses and the camera connection is closed. In this case, whenever you try to access any camera parameter, you are going to get the error message that the control channel is already closed. So, of course, there are many more error messages that you can come across, but I think these are the most two prominent, and they both are related basically to the complete setup. So, and the best way to prevent from error messages is, of course, to select the right hardware. So first of all, I want to start with cables, because cables are usually neglected in a system, but they are playing a significant role for the overall stability of the system. And our clear recommendation is to use industrial grade and qualified by Basler cables. And in our portfolio, we offer two options: the most cost-effective one, which are using full screening, and a premium quality, which is using braided screening. When we speak about network interface controllers, we clearly recommend using Intel chipsets. But not only Intel, we definitely recommend you using server chipsets of Intel, because they indeed give you the best performance and ways to optimize the performance within your application. Of course, one of the main advantages of gigabit Ethernet is that you can use switches, and by that connect multiple cameras to a single PC. So when looking for switches, I think two parameters are very important to consider. First of all, that jumbo frames are supported, and that the switch has enough memory per port. So a switch is a component just like a camera and a network interface controller. It must have memory in order to receive the incoming image data and then to forward it to the PC. So having a look at this parameter is always important. Of course, you can have unmanaged switches, which are typically cheaper, and smart and managed switches, which are more expensive. So depending on what you're looking for, you can select the one or the other. But of course, when using unmanaged switches, you usually have more configuration efforts. Okay, and here we start with the first tuning options for the network interface controller. And we start with some basics, for example, the jumbo frames. So jumbo frames are simply Ethernet frames with sizes bigger than 1,500 bytes. And the bigger the better. However, the maximum is currently at 9 kilobytes. So why is the bigger the better? So first of all, because this reduces the overhead. And according to the GigaVision standard, you always have a fixed overhead of 54 bytes per packet. So in this following diagram, you see how a typical GigaVision streaming packet is built of. And here it is the orange cover that we have a look at. You have some bytes reserved for the different protocol layers like IP, user datagram protocol, and the GigaVision streaming protocol. And you actually start here in gray cover with the Ethernet header and with a checksum that is used to check the integrity of any packet. So in total, you always have 54 bytes per packet overhead. So just to give you an idea how much overhead we can save by using jumbo frames, here we consider using a typical 5 megapixel camera with pixel format mono 8, which means 1 byte per pixel. So the total payload is 5 megabytes. In scenario 1, we don't use any jumbo frames, so packet size of 1,500. You see that this results in totally 3,354 packets to transfer a single image. In terms of overhead, this means that we have 181 kilobytes of overhead per image. In the second scenario, when using jumbo frames of 9 kilobytes, you see that we have 6 times less packets, and by that also 6 times less overhead. So considering that this camera is running at 14 frames per second, that means that you have here an overhead of 2.5 megabytes in the first case, which of course can reduce the maximum frame rate of the camera. So overhead is important, but I think even more important could be the CPU load that is generated by small packets. And indeed, when we use jumbo frames, the number of so-called CPU interrupts is reduced. And by that, also the CPU load of the PC. So these two aspects are, I think, the most important one about using jumbo frames. And the next parameter that is also very important when speaking about network interface controllers is the interrupt moderation rate, which in turn controls the so-called interrupt throttle rate. This parameter defines the trade-off between the latency, so how responsive the driver is to incoming packets, and what is the throughput performance of the network interface controller and also of the PC. So the lower the interrupt throttle rate, we speak about values of 400 or down to 200, the lower the latency, that means the driver is more responsive, but the higher the CPU load because we have more CPU interrupts. And on the other side, the higher the interrupt throttle rate, we speak about values of 3,600, the higher the latency, but the lower the CPU load because we have less number of CPU interrupts. So our clear recommendation for most setups is to use higher values for the interrupt throttle rate. That means 3,600. But of course, if you're working with very small packets and you're looking for very low latency, then going down with the interrupt throttle rate is a good idea. However, this will cause, of course, higher CPU load. And the third parameter that I want to speak about is the receive descriptors, or also called receive buffers. This basically defines how many buffers are going to be used by the host controller, by the interface controller driver to copy incoming data and forward it. So on Intel chipsets, the typical default value is 256 buffers, and you can go up to 2048. And this is, of course, our clear recommendation. And here we come to the first live demo, which is exactly about tuning of network interface controller parameters. For that purpose, I'm going to log on my test PC. And we can have a look at that. So I will simply make a right click here and go to Open Network and Sharing Center. Then we go to Change Adapter Settings. Then I will make a right click on this adapter and go to Properties. Here I will click the Configure button and go to the Advanced tab. So now here you find all these related parameters. Of course, you find even more parameters, but I think in terms of GigaVision, you are interested mainly in these three parameters that I just mentioned. And of course, jumbo frames is the first one. So by default, it is disabled. You have to make sure you enable it and put it to the maximum supported value. Then we have receive buffers, which you see is a default value of 256. So setting it to the maximum possible is our clear recommendation for that. And then you have the interrupt moderation rate. In this case, you have two parameters. One is to enable or disable it, and the second one that is controlling the interrupt throttle rate. By default, it is always set to adaptive, which means that the internet controller driver is doing something, but you don't have actually real control over it. And as I said, our clear recommendation for most of the setups is to set this parameter to extreme, which means in this case, interrupt throttle rate of 3600, for example. And as I said, if you're looking for low latency, and especially if you're working with small packets and need this low latency, then you can go for setting it to minimal, which is 400, or low, which is 200. And that's all for this live demo. Let's continue with some tuning parameters of GigaVision cameras. The first one is the packet size, which is the counterpart of jumbo frames on the network interface controller. So again, the bigger the better, but of course you have to make sure that your hardware also supports jumbo frames. So that means if you are using a switch, or of course you always use a network interface controller, you always have to make sure that these components also support jumbo frames, because if you simply set the camera to use jumbo frames, of course you are going to lose image data. The second one is the inter-packet delay, which defines a delay between every two stream packets. So when setting higher values for the inter-packet delay, you give more time to the network interface controller or the switch to receive packets from the camera, to copy them and to forward them. And this typically also prevents from collisions and image losses directly at the switch. The inter-packet delay, of course, because it introduces delay between the stream packets, it decreases at some point the resulting frame rate. So this is something that you always have to consider. And for multi-camera setups, this is, I would say, the most important parameter to share the bandwidth. And last but not least, I want to mention the frame transmission delay, which is an optional parameter according to the GigaVision standard. And by that, it is not supported by all third-party cameras. And this in turn means that in some setups, especially when you're using unmanaged switches, can prevent you from making this setup work. So this is something that you always have to consider, and it will directly influence, so to say, your decision on hardware. So this parameter defines a delay for the start of transmission of an image. So it basically introduces a delay for the very first packet of an image. And this is what we typically need when we have multi-camera setups with a switch, especially when we're synchronously triggering the cameras via a hardware trigger, action command or scheduled action command, or of course by using the time precision protocol. So where to find all these parameters in Pylon Viewer? You can always go for the command task here, and in this case, choosing the controlling the frame rate command task. And then in the transport layer, you will find all these parameters. So of course, you see even many more parameters than that, but I think these three are the most critical that we have to deal with. Maybe I can also mention the bandwidth reserve parameter, which is reserving a portion of the available bandwidth for the control channel. So that means for setting parameters and for resends. So in advanced setups, when you are pretty sure that you are not expecting too many resends, I suppose you can go down even to 2 or 3%, but that will be the maximum. And of course, whenever you need more information on parameters or you're looking for source code snippets, you can simply make a right click on any of these parameters here and select Get Help. Okay, so let's continue with some Pylon settings. First, I want to start with the maximum number of buffers. This is the amount of buffers that we're using in your application for grabbing. By default, this parameter is set to 10. And especially when your image processing is temporarily taking longer, we recommend increasing this parameter. In case you run out of memory in your application, of course, you are going to lose data. And this will be reflected by the buffer underrun statistic parameter, which I'm going to speak about later. So another parameter is the maximum number of queued buffers. This parameter is used to define indeed what is the maximum number of buffers used within Pylon, and it is used by the internal stream grabber, and by default it is set to 50. So why we need that, especially for GigaVision, this is a critical topic because the process of registering and queuing in buffer memory is quite expensive process and it takes long. So that's why internally within the stream grabber, we are using 50 buffers. And as you see by default in your application, we are using 10 buffers. So if you go for increasing the maximum number of buffers, you always have to make sure that it does not exceed the maximum number of queued buffers. Otherwise, it will cause delays and you don't want that to happen, of course. The next parameter is called number of queued buffers, which is a very useful parameter for you to control how stable your image acquisition process versus the image processing process is. So that means if you use 10 buffers by default and you use this parameter to see how many of these buffers are available for grabbing, and then you see that this parameter is going down to 0, that means that you are about to lose image data. So in the best case, this parameter will be always stable and not going down. What else? In Pylon, we give you the chance also to tune thread priorities. Although I will clearly say that for Windows, Pylon is already using real-time thread priorities, and you typically don't need to do anything. But for the sake of completeness here, I'm going to demonstrate how to do that either. So typically in Pylon, when you get the image data, it is by using the retrieve result method. And this method is exactly the one that is running in the application layer on this diagram. And as I said, by default on Windows, it is using a real-time thread priority of 24, while the maximum is 31. So in a very advanced and challenging setups where you need to increase that even further, you have to consider that internally in the so-called internal instant camera grab engine, we are using a second thread, which is this one. And this one has always higher priority than the application thread. So, and as you see, this one is also running at real-time thread priority of 25 out of 41. And if you go for increasing the thread priority even further, you can have the maximum, the following maximum possible setup, where the application thread will be set to 30 and the internal grab engine thread will be set to 31. Of course, in this case, you have to consider that the Pylon threads will be concurring with critical system threads. So that's why we actually don't recommend doing that. But I know in very advanced setups, some of our customers really benefit from that. Well, that gave them additional stability within their application. Okay, so let's have a look at some sample code about how to set all these parameters. And as you see in Pylon, because I set up to 60% list code to write, I think this is also pretty well demonstrated here. You see we have one line to enumerate cameras to get the first one and create a camera object. Then we here set the number of buffers we want to grab, then open the camera, set the priorities of these two threads that I mentioned, and after start grabbing without further configuration, as you see, you can use the number of queued buffers in order to control how stable your acquisition and image processing threads are. So, and as you see in this complete sample, so we always go for setting any parameters from the camera object. So we have only one camera object for setting anything, despite of stream grabber or chunks or events or anything else. Okay, what can you do if you run into some troubles? So in Pylon Viewer, you can select the command task checking whether the camera is losing image data. And then in the statistics section, you can find some statistic parameters. I will focus on two of them today. And the first one is the failed buffer count, which means that here you grab an image that has at least one failed buffer. The second parameter is the buffer underrun count, which clearly indicates that your application is running out of memory and that you have to increase the amount of memory, or of course, make sure why your image processing is taking so long. So of course, you can have here some failed buffer count or recent counters, but I think they are more as a warning than really a typical error messages. So let's have a look at some sample code for using these statistic parameters. And this is now a complete, let's say, pylon sample, I would say so, because as you see here, we create a camera. We start grabbing without further configuration of stream grabbers, buffers, and so on, because we're using a standard configuration for the camera. And when you retrieve the image data here, you can simply access these statistic parameters and print their values out in the terminal in this case. So pretty straightforward, pretty easy. So let's come to multi-camera setups when using a switch. And of course, in such a setup, the main advantage, or there are two main advantages, is first of all, you can connect multiple cameras to a single PC or to a single adapter. And the second advantage is that you can easily double or even extend the cable length, which is for a peer-to-peer connection 100 meters. And of course, in this setup, the bottleneck or the potential bottleneck is the fact that the switch has only a single connection to the Gigi adapter in this case, and the cameras must share the bandwidth. Okay, sharing the bandwidth sounds easy, but it could be also quite tricky. And this, of course, strongly depends on the switch that we're using. For example, if it's a unmanaged switch or it is a smart managed switch, and of course depending on the fact how much buffer memory per port the switch supports. So typically, despite of the switch, we are looking to serialize the data of the cameras reaching the switch. And when you reach the serialization of the image data, you typically also prevent from packet collisions and from image losses at the switch. And on the next slide, I'm going to demonstrate exactly that. So, and this is especially critical for those setups when we synchronously trigger cameras. And these are, of course, when using the hardware trigger, the time precision protocol, action commands, or scheduled action commands. Here we consider using 4 cameras. And on the x-axis, we have the time. On the y-axis, we have the trigger. So the point when we trigger all these 4 cameras simultaneously. And we have the point when the cameras start sending the first packet of an image. So in this setup, we consider using packet size of 9,000 bytes, so jumbo frames. And as I said, a Gigi Vision streaming packet is telling you not the full story. So that means we always have to consider the overhead caused by the Ethernet protocol and by the cyclic redundancy check, by the checksum at the end of the packet, which are additional 18 bytes. So the total IP packet size will be 9,018 bytes. So when speaking about serialization, of course, we have to calculate some delay between the separate streaming packets. And for that purpose, we are using a very simple formula, which is the IP packet size multiplied by the number of cameras minus 1. And the second parameter that we need to calculate is the frame transmission delay. So when the camera or the cameras will start sending the first packet. And also for that purpose, there is a simple formula to apply. So for camera 0, it is the IP packet size multiplied by 0, which is 0. So that's why we have for the first camera here 0. Then for camera number 1, it is the IP packet size multiplied by 1, and so on for the other cameras. And as you see by that, we reach exactly this serialization for sending on the first packet of an image. And then, of course, for the other packets of the image, we apply the same inter-packet delay to all the other cameras. And by that, as you see, in this case, we have a serial data transmission to the switch. And by that, the switch has enough time to copy packets and to forward it to the PC. So as you see, in this setup, we reach exactly this serialization and can guarantee that even with unmanaged switches, you have no image losses. So the math is good. And how about doing all this math with just a few clicks? For that purpose, we are offering you our Pylon Bandwidth Manager, which currently supports Gigi and USB cameras. And of course, the implementation here for the different protocols is different. So if we focus on Gigi Vision only, you can consider that the Bandwidth Manager will automatically optimize exactly these 3 parameters: the packet size, the inter-packet delay, and the frame transmission delay. And for splitting up the bandwidth, it applies the so-called fair manner principle. That means that every camera that you want to configure gets the same amount of available bandwidth. So, and here we come to the second live demo today. So for that purpose, I'm again moving to my test PC, and we'll simply start the pylon viewer. So in the pylon view, now we have two Gigi cameras, one USB camera. Of course, you don't see these two cameras are connected to a single network adapter. So that's why I'm shortly going to open the IP configuration tool. And as you see, these two are connected to this adapter, which means they are connected by a switch. Okay, so let's open the first camera. So for today's webinar, I have already prepared a customized tab called Features Gigi Troubleshooting. If you are looking to doing something like that yourself, you can simply go from Features O and Edit Feature tab and simply drag and drop the parameters that you're looking for. And then by that, you get your own customized tab. So here, what we see are mainly the parameters that I'm interested into today. And the first thing to notice is that this camera, which is having this resolution and is quite fast camera running at 274 frames per second, this camera, these settings requires the full bandwidth, which is 112.5 megabytes in this case. So I can start it, and we can have a look at the statistics section here. So everything is working fine so far with this camera, even without using any jumbo frames, even without setting any of these three parameters that I just mentioned. So what happens if I decide to start a second camera? So for the second camera, we see that this camera needs also like 63.5 megabytes, which is simply too much bandwidth for this switch. So what can happen if I now start also the image acquisition of this second camera? So as you saw, both cameras now start losing image data. You can see it here and there. And I expect that, of course, at some point, we're going to lose the connection to one or to both cameras. So, and this is exactly what happened. Both cameras now has been lost. Why? According to the GigiVision standard, a so-called heartbeat timeout packet must be sent regularly to cameras to make sure that the connection is alive. And if this does not happen within 3 seconds, then the connection to the camera is closed. And this exactly happened because of the massive image losses at the switch. The so-called heartbeat timeout could not reach the camera, and the connection to the cameras was lost. So, question is here, how to make it now working fine? And of course, you can now start manually tuning and calculating things, but our recommendation is to simply use the bandwidth manager. And when you start it here, you have two options. When you click optimize Gigi bandwidth, all available cameras will be optimized. And I don't want to do that. I will go for OK, which means that I'm going to decide which cameras I actually want to optimize. And now when I select these two cameras, you see that the bandwidth is clearly exceeding the total available bandwidth. So now when I click on the optimize button, please have a look at exactly these three parameters in the background. And when I do so, you see that, first of all, here the bandwidth was split up in a fair manner principle, so to say. And as you see here, the packet size was set to 9,000. So in this case, the bandwidth manager confirmed that the network interface controller and the switch are both supporting jumbo frames. And then, of course, the supported size was checked and then set to the maximum supported one. The interpacket delay was used to split up the bandwidth, and the frame transmission delay was also optimized for synchronous acquisition. So in this case, when I start, let's say, the image acquisition on the first camera and also on the second camera, we expect to have no issues any longer. And of course, we can have a look at the statistics section here. You see that everything is clear. So, and this is it for this live demo. Let's continue with the next one. And here we go with optimizations on Linux. So first of all, I want to make sure we have a common understanding that Linux is a completely different operating system. That means the Linux kernel has a different implementation from Windows. The driver of the network interface controller has also partly different implementation, and so the pylon camera driver. So that means we have partly different things to tune and to configure here on Linux. And of course, when you're looking for, let's say, supporting Windows and Linux with the same application, you have to consider that either. So, and I first want to start with some system settings. Yeah? And before I show you some parameters, I want to highlight that within our Pylon README file, which is available both in the Pylon Linux packages and also available on our website, we have a lot of helpful information, and especially for troubleshooting, there are a lot of tips and tricks that you can read about and apply within your application. So please have a look at it. So first parameter that you have to set on a system level is to allow Pylon threads to use real-time thread priority. So how to do that? It is simply by adding the following line, real-time priority set to 99 within the limits.conf file. So whenever you change this file, you always have to log off and log on in order the changes to take effect. The second parameter that we have to consider is to increase the maximum user datagram protocol receive buffer size. So what is that? According to the GigaVision standard, both the control and the streaming protocols within GigaVision are based on the user datagram protocol. And on Linux, especially on Linux, we depend strongly on the system settings of the user datagram protocol. So by default, the buffer size is set to something like 200 kilobytes. Of course, it could be different depending on the Linux distribution, but the default value is always actually pretty low. So depending on, of course, on your camera or camera setups, you need to increase it. So, and in this case, we show you a command line that you can execute. Of course, you always have to have administration rights, which on Linux is called super user do. And then in this case, use the system CTL tool in order to increase this UDP receive buffer size. In this case, it is simply for demonstration purposes set to 4 megabytes. But as I said, depending on your setup, how many cameras, what kind of cameras, what settings, and so on, you can or you must increase it even further. Okay, so let's have a look at some network interface controller parameters. And of course, we have jumbo frames also on Linux. However, here they are called maximum transfer unit or MTU. And you can, of course, again, the bigger the better for reducing the overhead and for reducing the CPU load. And you can tune them either by using the if config tool and do that in the terminal, or of course, using the graphical user interface on your Linux machine. The next parameter is the ring size, and I suppose this is comparable to the received descriptors on Windows. However, as you see here, we have slightly different ranges. And to be honest here, in this command line, we're setting both the receive and the transmit ring sizes. In terms of GigaVision, we are mostly, let's say, interested in changing the receive ring size, because this is where the incoming packages from the camera are coming to the interface controller driver. So in this case, we are setting them to maximum, which is 4096, and this is also our recommendation to do so on your side. And of course, also here we have the interrupt moderation rate, which controls the interrupt throttle rate of the driver. And again, the lower the value, the lower the latency, but the higher the CPU load. So here, one thing to mention is, of course, before you go for changing these settings here, you always first have to make sure that you switch off the adaptive interrupt moderation rate. And here the settings are different because here we are setting them in microseconds. So this is a reciprocal value probably of 3600 on Windows. But also for more information on Linux, especially when using the Intel chipsets, you can refer to Intel documentation. I think Intel is providing very, very good documentation with a lot of information also on tuning of other parameters that you can be interested into. Okay, so let's go for tuning Pylon parameters. And on Pylon, again, we have the receive thread priority. However, on Linux, we have different ranges. So as I said, this parameter is strongly dependent on the first parameter that I showed about the system settings. And when you have allowed Pylon to use real-time thread priority, then Pylon is going to use thread priority of 50. However, the maximum is 99. And then, of course, if you allow to use real-time thread priority within Pylon, you can, of course, go for 99, which is the maximum. Then within Pylon, you can set also the so-called socket buffer size, which again is dependent on the UDP buffer size. This is the second parameter that I explained when setting the system settings. So when you have first increased the UDP buffer size, you can also tune the socket buffer size within Pylon. And of course, our clear recommendation is to use bigger sizes, like for example, 2048 or even bigger, depending on your setup. So let's have a look at some sample code. And again, this is pretty straightforward, pretty easy to apply. You create the first camera, open it, set the receive rate priority. As I said, in this case, we set it to maximum, which is 99, and increase the socket buffer size to 4096. And here, just for demonstration purposes, again, how to set the packet size and the inter-packet delay within the camera. So, and here we come to the next live demo, which is on Linux. So for that purpose, I need to switch the test PCs, which can take a little longer. So here we go. Okay. So we have here two terminals. I will simply launch the Pylon viewer from the terminal and directly open the Gigi camera in this case. As I said, you can always use our command tasks to easily find things. And I will simply here select the checking whether the camera is losing image data and directly jump into the stream parameters. So what you first here see is, as I said, receive rate priority is set to 50, which means I have already applied the system settings that allows Pylon to use real-time rate priority. In the feature properties, you see that the maximum is 99. Yeah. So that means here, if I enable this parameter, now I can go for 99, which is the maximum on Linux. Second parameter that I mentioned is the socket buffer size. And as you see, this is pretty low. It is only 208 kilobytes on my machine, which, as I said, is a typical issue for losing image data on Linux. That's why I'm going to close the Pylon viewer, make exactly the setting that I demonstrated to you already. In this case, probably I will simply set it to, let's say, 4 megabytes. Of course, you need to have administration rights. And when I do so and launch the Pylon viewer again, open the camera, go to the stream parameters, you see that the socket buffer size now is set to 2 megabytes. However, I can set it up to 3,906. So, and this will be something, as I said, this will be the two settings that you definitely have to apply within your application in order to get the maximum possible performance. And of course, I will start the camera so that we see this is an 8 megapixel camera, which is also using the maximum possible bandwidth on Linux. And as you may see here in the statistic section, of course, we are running pretty fine. You see, we had one resend. So I suppose if I did not make these settings, we could have lost an image right now. So, but everything is working fine. And well, this is all about this live demo, basically. So by that, let's continue with USB 3 vision optimization settings. And here I want to start again with some typical error messages that you may come across when using USB 3 hardware. First one is a typical error message which you can see on Windows. And as you see, this is a typical Windows error message, which tells you that a device is not functioning. So, of course, in this case, you don't know what's going on. But whenever you see it, I tell you this is an issue of the complete setup. So complete setup means camera, cable, host controller driver, and even a USB implementation in the motherboard. So this is an issue not only of a camera, this is a clear issue of the complete hardware setup. So, and the next one is then a Pylon error message. And you see the great difference between a Windows error message and a Pylon error message, because in this case, this occurs when you cannot open the camera, for example. And here we clearly state, okay, if this happens, you have to check if you are using the right host controller, the right driver version, the right cables or the right cable lengths, and have to check them in order to solve the problem. So, but here again, also this error message reflects that the complete setup is not okay. The next one is also a very severe error message, which tells you that the image stream is out of sync. So in this case, obviously, you could have opened the camera and you started image acquisition, but because of very massive image and low-level errors, the host controller has to reset the connection to the camera. And in this case, all the images that are buffered inside the internal camera memory will be skipped. And typically, when you get some of these error messages, you eventually may end up with the first error message that the operating system tells you the device is not working. And for all these three error messages, as I said, you have to check your complete setup. So it's not a pure camera or software issue. No, it is a topic for the complete setup. And the last error message that I want to speak about is probably the most prominent of all of them, which is simply telling you that you're losing image data. So the reason for losing image data is typically insufficient bandwidth. And of course, this is something that you can work around. Insufficient bandwidth means not available bandwidth on the hardware. That means the host controller, or maybe the hub if you're using hub. Maybe the cable is limiting the bandwidth. Or of course, it could be a reason of the memory that you're using for grabbing within your application. So, and on this error message, of course, you can do a lot of optimization things in order to prevent it from happening. And of course, we're going to focus on that today. But again, the first and the best practice to prevent from error messages is to select the right hardware. And again, and I think this is even more critical on USB than on Gigi, is that it is really recommendable that you use industrial grade and qualified by bus-like cables, because using bad cables is the most typical reason for having issues on USB 3. So next, using recommended host controllers. Of course, we recommend using Intel host controllers. They have the best performance, and to be honest, they support even more bandwidth than the officially supported USB 3 bandwidth. So that's why, even in multi-camera applications, using a single Intel host controller could be sufficient for running multiple cameras at full bandwidth. If you're looking to extend the ports on your PC and connect even more cameras, then we recommend using Fresco Logic and Renesas host controllers. And for both of them, we have some adapters in our portfolio. Then a topic that is typically neglected is to use the latest host controller drivers. So this is, of course, with Windows 10, it is a bit tricky because Microsoft provides you with a universal driver for all hardware. But even on Windows 10, of course, you can also install a native driver for the given hardware. And this is also, especially for advanced setups, also always a good idea. So this is a very important topic because, as I said, using some old versions of drivers is also a typical reason for losing image data, for having resynchronizations, and so on. And last but not least, if you are about to use hubs in order to connect multiple cameras to a single port, then of course, please use industrial grade and qualified by Basler hubs. And also we offer one hub within our portfolio, which we recommend using. So let's start with some settings, camera settings to control the bandwidth. And there are actually two parameters. The first one is the device link throughput limit mode, which simply enables or disables the bandwidth control. And the second one is the device link throughput limit. As you see, again, going through the command task here. And the device link throughput limit can be set in bytes per second. That's why the numbers are typically big, because you're working in millions of bytes. Okay, so let's continue with tuning pylon parameters. The first one that I want to mention is the maximum transfer size. Well, you can compare this parameter with the jumbo frames on GigiVision. However, on USB, the maximum transfer size goes up to 4 megabytes, which is of course much bigger than what we have on Gigi. And of course, this is also one of the reasons why we have much lower CPU loads on Windows and of course also on Linux, because using, let's say, 4 megabytes means that you decrease the overhead and of course decrease the amount of CPU interrupts. So The next parameter is the number of maximum queued ERBs. ERB stands for USB request block sizes. This is the definition of packet size in the protocol and actually in the USB 3 protocol. So whenever we transfer information via the USB 3.0 protocol, we use the so-called USB request blocks. And as I said, for streaming packets, they could be as big as 4 megabytes. Just to understand now what is the dependency between these two parameters, and as you see, the default value for this parameter is 64. But to understand the dependence between these two parameters, I have prepared the following diagram, which explains or describes the transition from the USB 3.0 protocol layer and the USB 3 vision layer. And this is also the transition between the USB host controller and the pylon implementation and also the camera implementation. So as I said, in the USB 3 protocol, we use the so-called USB request blocks to transfer information, both control and streaming. And in the USB 3 vision layer, we use the maximum transfer size to define how big our payload or stream packages are, so to say. So imagine you have a 20 megapixel camera. That means the payload here could be as big as 20 megabytes. And you want to transfer that. Well, however, the maximum size for the maximum transfer size and for the ERBs is 4 megabyte if the host controller supports that, of course. So for a 20 megapixel or megabyte payload, we will need at least 5 of these USB request blocks to transfer a single image. So keeping in mind that we always have a leader and a trailer packets, which are typically very small, but we still need a USB request block for them. So in this case, we can have 7 USB request blocks per image. And this parameter is defining exactly that. How many USB request blocks will be used in our setup? So, and yeah, depending on how many cameras, what settings you have, you might need to increase this value in order to prevent from losing data. Okay, what else? In Pylon, of course, we have also for USB 3 vision the maximum number of buffer, which defines how many buffers you use within your application for grabbing. And as I said, if your image processing takes temporarily longer, then it's probably a good idea to increase the value of this parameter. So here I again want to mention the number of queued buffers, which is giving you the chance to control how stable your image acquisition and image processing processes are. And clearly, when this parameter goes down, you can expect that you are going to lose data. Then on USB, we have one additional transfer loop thread priority that you can tune. And this is called the transfer loop thread priority. This parameter is strongly dependent on the fact if you are running your application with administration rights or not. If you are not having administration rights, then your application or this thread is going to run at a thread priority of 15, which is not real-time thread priority. And if you are running your application with administration right, then the default setting will be 25, which is a real-time thread priority. And this is also a typical reason for losing image data on USB 3 setups. So where to find all these parameters in Pylon Viewer? Again, you can use the command task feature and go to stream parameters here, and you find all these parameters here. And as I said, whenever you need some source code snippets or additional information, simply make a right click on these parameters, and then you are going to be forwarded to the master plan documentation. So let's have a look at some sample code, how to set all these parameters. And again, a single line to enumerate, find, create one camera, set the maximum number of buffer, set the maximum transfer size to a maximum possible value, increase the maximum number of queued USB request blocks, increase or set in this case the transfer loop thread priority to 25. And here, for the sake of demonstration purposes, it is demonstrated how to control the bandwidth. And as I said, when you start grabbing, you can use the number of queued buffers to control the stability of the image acquisition and image processing threads. Okay, so what can you do when something goes wrong? And again, in Pylon, we recommend using the statistics section, and I here want to focus on mainly on 3 parameters. The first one is the failed buffer count, which indicates that images have been corrupted Yeah, this is a typical, as I said, reason for having some hardware issues. Then the miss frame count is actually indicating that something with the bandwidth is not okay, or probably your application is not having enough memory also. And when this happens, when this starts increasing, that means that the camera starts keeping newly acquired from the sensor image data. And last but not least, as I said, the resynchronization count is probably one of the most severe error messages in USB 3.0 and USB 3 Vision, which simply tells you that the errors on the line were so massive that the host controller had to reset the connection to the camera. And by that, of course, all buffered images in the camera are lost then eventually. So as I said, in this case, you definitely have to check the complete setup, starting with the cable, host controller, and so on. So let's have a look at some sample code for accessing these statistic parameters. And again, you'll find create open camera, start grabbing without further configuration. And in the grab loop, you simply access these statistic parameters from the camera object. So pretty straightforward, pretty easy. And here we come to the next live demo, which is again on Windows. For that purpose, I'm going to log off here and again switch to my Windows PC. Oh, sorry. This is not what I wanted to do. Okay, so let's launch the pylon viewer. Open, in this case, a 20 megapixel camera running by default at 70 frames per second. Again, I have prepared for today one customized tab so that we have a compact view of all related parameters. Well, the first thing that you can have a look at is the transfer loop rate priority, which is set to 15. And as you see, we cannot increase it even further. And this is exactly what I said. So if you are launching your application without administration rights, then the pylon transfer loop rate priority is not going to be a real time. So that's why I'm going to close the pylon viewer and now launch it as an administrator. And in this case, you see that the transfer loop rate priority is automatically increased to real time, so 25, and you can go up to 41. So please think about that. So the two parameters for controlling the bandwidth, in this case, as you see, when the parameter for controlling the bandwidth control is switched off, we have 380. If you want to control the bandwidth, you can switch it on, and then we have 360 in this case. So what else? The maximum transfer size, as I said, the bigger the better. And everything works fine now, even at 19 frames per second, because we're using the full bandwidth. And of course, we can have a look at the statistic parameters, so no issues in this case. The question is here how to simulate potential issues. Of course, it's difficult now to find bad hardware when we can demonstrate that, or maybe now connect multiple cameras to exceed the available bandwidth. So I think the most easiest way to demonstrate what happens when you have a lack of bandwidth is just to set the maximum transfer size to 1 kilobyte. So in this case, we have a 20 megapixel camera running at 19 frames per second, yeah, and a total bandwidth of 380 megabytes per second. And we want to transfer that amount of memory or of image data while using a 1 kilobyte packets. Then, of course, there is no way that this will work fine. And as you see that the miss frame count here is start counting. This is exactly the point when the internal camera memory overflows, so to say, which in turn results to skipping any newly acquired image data from the sensor. And as you see, also, of course, the resulting frame rate has dropped down to 5-6 frames per second. So this is exactly what will happen if you, let's say, using multiple cameras on a PC, or when you're using a hub and you simply do not configure the cameras correctly and don't have enough memory or not enough bandwidth, sorry. And well, that's all about that. It is pretty simple on USB indeed. And by that, I'm moving to the last chapter for today, which is optimizations on USB 3 vision setups on Linux. And here I want to focus actually only on the system settings, because everything that I already explained about USB 3 on Windows is the same in terms of pylon and camera settings. So when speaking about system settings on Linux, I again want to recommend reading the README file, which is part of the pylon installation and available on the website. And the first thing, again, what you have to do on Linux is to allow pylon threads to run at real-time thread priority. And again, this is simply done by adding the following line to the limits.conf file. And again, always think of logging off and logging on. The second very important parameter, and this is I think the reason for most of the USB problems on Linux, is the so-called USB file system kernel space member. So by default on Linux, all USB devices are sharing a total bandwidth of 16 megabytes, which of course, if you're using a 20 megapixel camera, could be insufficient. So in order to increase that, you can use the following command line. And in this case, the USB file system kernel space will be increased to 1 gigabyte. But well, depending on your setup, what camera, what settings, how many cameras, and so on, you might need to increase it even further. So there is not a golden rule how to calculate that. Instead, we always need to consider what kind of setup you have, and then we can, so to say, try to find out what are the optimal settings. But starting with increasing this value to some, as I said, depending, of course, on your system. If you're working with embedded boards and Linux for ARM, well, it could be, of course, tricky to use gigabytes of memory. Yeah? So that's why, as I said, it always depends on the setup. The next very critical parameter is the so-called file handle limit, or also file or descriptor handle limit. You can imagine when we deal with these USB request blocks, for every USB request block, a so-called file is opened on the Linux system. And per process, the number of files that can be opened is up to 1024. And of course, depending on your setup, how many cameras, what packet sizes, and so on, this could be insufficient and a reason for losing data. So that's why, again, in order to improve the performance of that, you can simply add the following line to the limits.conf file. And again, you have to log off and log on in order the changes to take effect. For the last two parameters, you can also simply use the setup minus usb.shell script, which is within the pylon installation, which in turn is going to set some default or improve default values for these last two parameters. Okay, and last slide for the technical part is to demonstrate you some sample code, and especially I'm going to here focus on the differences between Windows and Linux. And as I said, transfer loop thread priority has different ranges on Linux, while here the maximum is 99. And as I said, this setting, of course, depends on the system setting for real-time thread priorities. The next one is here one statistic parameter that I did not mention on Windows, because you typically don't see it there. You typically see this error message on Linux. And the so-called statistic out of memory error count reflects exactly this use case where you don't have enough memory in the USB file system kernel space. And this is, of course, for you an indication that you have to increase the kernel space for the camera to have more memory. And this is the last slide about the technical part. So let's summarize the session. And yeah, today I started with speaking about the brand values of Pylon. And I focus on the reliability aspect of Pylon. And as I said, and I think I also demonstrated it today with the source code snippets that I showed you, you definitely write much less code within Pylon. The probability to make mistakes is lower. Of course, your application then will be easier to read and easier to maintain after all. But what I mainly focus on today is the aspect of Pylon being field proven, optimized, and robust. And as you saw, Pylon is indeed already optimized for real time, but it gives you even more possibilities to tweak it and to get the last percentage out of your application, or let's say the last percentage out of the system and Pylon and camera settings to get the maximum performance for your application. So, and that's all from my side. So thanks a lot for listening, and I'm really curious to get your questions now. So back to you, Zoran.
Thank you,
In the time
Monche,
bank,
for these.
sorry, in the time bank, you can scan the QR code to read more about upcoming webinars on our website.
Yeah, perfect. Thank you, Momche, for these interesting insights on how to optimize your vision application for real time and high performance. During the presentation, we've received a considerable number of questions from the audience, and I would like to give you the next 9 to 10 minutes to reply to as many questions as possible. So we have to keep it short if possible. First question. I use USB cameras on Linux, and when I increase the maximum transfer size to 1 or 4 megabyte to reduce CPU load, I get error messages in the terminal. Why?
Okay, good one. I will close the camera because it's difficult to work with all these windows on one monitor. Well, probably it's a good idea to demonstrate that on Linux, so that everyone gets an idea of what we speak about. And here we go. So basically what you said is that when you're using your USB camera on Linux and you go for increasing the maximum transfer size to 4 megabytes, you are getting error messages. Let's have a look at the statistics section. I start the camera now, and what you might see here is the out of memory error count, and this is exactly what I said. If you are trying to use, let's say this is a 2 megapixel camera now. We're using 10 buffers, yeah, and that means 10 buffers, 2 megapixel, 2 megabyte. We are running at 20 megabytes, and actually the Linux system supports only 16 megabytes. So that's why we get this out of memory error count counting high, which means that in this case, as I said, you have to optimize the system settings. And to do so, we can basically look for, let me look for, okay, this command line will be fine. So if you, let's say, increase it to 1 gigabyte in this case, and as I said, you have to have administration rights for that. And then launch the Pylon viewer again. Go to the camera. Here again, set it to 4 megabytes. Again, open the statistics section, start image acquisition. So you see now it stays stable at 0. And this is the reason why you see the error messages. And that's all. Zoran, back to you.
Yeah, next question. On slide 16, you talked about max num buffers. What in that context is actually meant by buffers? What does a buffer contain?
A buffer contains memory on the on your system, of course, on your machine. It's a RAM memory usually. Yeah.
Okay. Next question. What would be the best way to trigger 2 or more USB cameras synchronously in a fast application?
Okay, triggering of USB cameras synchronously. Is the question always what is synchronous for you? If you mean, for example, hardware trigger, then of course you can simply use hardware trigger to trigger the USB cameras, and then this is the only way for USB 3 to trigger synchronously cameras. Of course, it depends always on you, what you understand. And the synchronous is, for example, having a delay of 1 or 2 milliseconds is still acceptable. Then, of course, you can also use software trigger. But clearly, you don't have the same mechanisms like on Gigi Vision, where you can use action commands or scheduled action commands or PTP. Simply, the USB 3 protocol does not support such features. So that's why the only chance for you to trigger cameras is hardware trigger or software trigger.
Okay, then the next question. Can we use Gigi cameras with OpenCV?
Sure, you can use both USB Gigi cameras with OpenCV. I believe we also have application notes on our website. I don't need to go now on the website and show you. Just simply have a look at our website and go for downloading documents, application notes, and there is an application note for Pylon and OpenCV. Yes.
Perfect. Then how are the maximum values of every parameters calculated? So max transfer size, max bandwidth. Is it the result of a negotiation between the camera and the host? The recommendation is to use always the highest as possible.
No, there is no negotiation. If we consider, let's say, maybe I can show it also here. Maximum transfer size, this is a parameter that you have to set. So in Pylon, we have some default values that has proven to be, let's say, optimal for most setups, but this is nothing that you negotiate. So let's say considering USB 3, of course, you can have a Basler Dart or Pulse camera connected to a USB 2 port. Then, of course, there is some handshake for checking, let's say, what is the power consumption of the device and the host control and so on, and defining what is the speed supported. But what type of maximum transfer size or what value of that you use, this is something that you have to set yourself. And as I said, within Pylon, we use simply default values that has been proven to work fine on the most setups. So this is also the reason, by the way, here, let's say if I close the camera and open it again, that's why we use on Linux 262 kilobytes, and on Windows we have a 1 megabyte for the maximum transfer size, because on Linux it is really a question of how much memory you have on the system. And as I said, these 16 megabytes are limiting factor. So if we are here using 1 megabyte and you open here 20 megapixel camera, it will simply not work. And then we have to tell you, okay, decrease this and do that. So that's why we are using default values that typically work, so to say.
Okay. And as we are only 1 minute in front of time, but still there's flowing in more questions, I again want to make everyone aware that we will have an extended Q&A session. So the last question for the regular webinar now would be, you have demonstrated using Gigi and USB cameras on Linux. Do you plan to provide support for Android also in combination with mobile devices, for example, smartphones or tablets?
Well, yeah, that's interesting question. Well, typically, I'm not willing to reveal internal information, but I think in this case it is suitable to do so. We are indeed close before releasing a Pylon version for Android, and especially for supporting USB 3 cameras on Android. And yes, this will come true. The timeline is set for middle of November. And this is interesting that you ask about that. If you have ideas or questions, please feel free to get back to us. But if you don't do so, yes, in the middle of November, stay tuned for a new Pylon version with Android support.
Perfect, thank you. Unfortunately, our time has ended and we need to finish our Q&A session at this point. For those of you who still have time and are interested, please feel free to stay with us. More questions and conversation on this very interesting topic. For this extended session, we will have Monchel available, but I also would like to welcome Jörg Weigt from our customer service department. You may ask your questions as usual, and I can read it out loud, or if you prefer, you can raise your hand and I can unmute your mic. As for the rest of you, thanks again very much for listening and participating in our webinar. For your convenience, this webinar has been recorded and will be available on demand shortly. Before you leave, we kindly ask you to fill out our survey, which will help us improve our performance for future webinars. Speaking of future webinars, please feel free to check out our upcoming webinars in our news section on baslerweb.com, featuring the most discussed topics in computer vision technologies. Stay tuned and see you next time.